In this video, I'm going to reintroduce you to a special parallelogram called the rectangle. Now, because a rectangle has two pairs of parallel sides, it fits under the umbrella of being a parallelogram. But in addition to being a parallelogram, it has a little something extra going for it. And the little something extra that it has going for it is that it also has 4 right angles. So what you really need to know about a rectangle is that in order to join the rectangle club, you really have to have 4 right angles. If you have 4 right angles, you're in. If you don't have 4 right angles, you can't be a rectangle. Now, because a rectangle is a special type of parallelograms, it still has all of the unique special properties and characteristics of the parallelogram. But in addition to those, it also has the fact going for it that the diagonals are congruent. So if we label this picture over here ABCD, we know that diagonal AC has to be congruent to diagonal BD. And as I discussed already, we know that all the angles are right angles. And we can take that one step further even, and because all the angles are right angles, we know that all of the angles have to be congruent to each other. If you want, you can add that little property or that little characteristic in there. All right, so let's go use what we know in order to solve some problems now. Number 1 talks about rectangle ABCD. So the first thing that I'm going to do, because they don't give me a picture, is I'm going to sketch this rectangle. I'm going to make this a nice big picture. No wimpy pictures for us here. Remember that as you label the vertices of any polygon, you either need to proceed around the polygon in a clockwise direction or a counterclockwise direction. It doesn't make a difference because in either case, A and C will end up opposite angles, as will B and D. Now I'm going to go label the given information in the picture. It says the length of segment AB is 15 centimeters, the length of segment BC is 6 centimeters, and they want us to find the length of either diagonal in simplest radical form. Well, I'm going to go ahead and sketch diagonal AC in there. And the reason I like just putting one diagonal in is because this diagonal divides the rectangle up into 2 triangles, both of which, due to the nature of the fact that this fella is a rectangle, happen to be right triangles. So in essence now, what I have going on in the upper right-hand corner of this picture is I have a right triangle where I know the lengths of 2 out of the 3 sides. So in order to find the length of the diagonal, the third side, or the hypotenuse of this rectangle, I can go ahead and I can use Pythagorean theorem. Remember that anytime you use Pythagorean theorem, when you substitute in, you need to make sure that the hypotenuse goes in for your C value. Your A and your B represent the lengths of the 2 legs. So it doesn't matter which one you put first, but your 2 legs have to be the 15 and the 6. So I'm simply going to now substitute or plug into my calculator the expression 15 squared plus 6 squared. And then in order to undo squaring something, I'm going to take the square root of both sides. And there are my favorite words, simplest radical form. So I need to now go see if the number 261 contains any perfect squares. I know that I can't take the square root of 261, but it does have a factor, 9, that's a perfect square. So I can rewrite the square root of 261 as the square root of 9 times the square root of 29. The square root of 9 is really a fancy name for 3. And 29 here is a prime number, so I know that not only can I not take the square root, but I also know that it doesn't have any factors that are perfect squares. So I like 3 square roots of 29 for example 1. Example 2 also deals with a rectangle and its diagonals. And like example 1, it doesn't have a picture. So the first thing that I'm going to do is draw a nice, good-sized sketch that I can work with here. So this one talks about both diagonals, and for that reason, I'm going to put both diagonals in my picture. And it says the point of intersection of these two is at point E. So A to E is 10x plus 20. C to E is negative 4x plus 76. And they want us to find the length of diagonal BD. Well, if I knew the length of diagonal AC, I'd also know the length of diagonal BD, because in a rectangle, they're congruent to each other. Because this person is a rectangle, I know his diagonals bisect each other. That's one of the properties of the parallelogram, and all rectangles fall under that parallelogram umbrella. So because the diagonals bisect each other, I now know that the length of segment AE is equal to the length of segment EC. And that gives me what I need now to go ahead and write an equation to get this problem rolling. So 10x plus 20 is equal to negative 4x plus 76. I'm going to add 4x's to both sides. The reason that I chose to add 4x's to both sides is that on the right side, a negative 4x and a positive 4x become a 0. So now subtract 20 away from both sides and divide both sides by 14, divide both sides by 14, and you find that the value of x is equal to 4. Unfortunately, though, they didn't ask us to find the value of x. They asked us to find the length of BD. Well, I'm going to use x now to go find the length of AE and the length of EC, add them together, which will give me the length of the first diagonal, and I know that's equal to the length of the second diagonal. So 10 times 4 plus 20 gives me 60 for the length of AE. And I can do the same thing for EC. And this is a nice little check that indeed what I've done is correct, because these two come out to be exactly equal. So if these two are each worth 60, I know that the length of the entire diagonal is 60. And if one of the diagonals in a rectangle equals 60, I know the length of the other diagonal has to be 60 as well. All right, number 3 is a good little question. This one wants us to think a little bit. It says we're given a quadrilateral that also happens to be a parallelogram, and one of the angles is a right angle. They want to know, is this enough to prove that the quadrilateral is a rectangle? And then our favorite words, explain your answer. Well, I'm going to go ahead and start with a parallelogram that contains a right angle. So a parallelogram has to have opposite sides, both pairs of opposite sides that are parallel to each other. And this particular parallelogram contains one right angle. Well, because in a parallelogram, opposite angles are congruent to each other, I know if that angle up in the upper left-hand corner is a right angle, I know this fellow down here has to be a right angle as well. And I think I'm going to go ahead and label this parallelogram math, just so that we can have some things we can talk about. So angle T is also a right angle. Because parallelograms has opposite angles that are congruent. I also know that every parallelogram has consecutive or adjacent angles that are supplements. So I know that angle A and angle T must be supplements of each other. Well, if angle T is a right angle with a degree measure of 90, I know that angle A has to also have a degree measure of 90, making it a right angle. And the same thing over here is true for angle H. Angle H either has to be supplements to angle M and to angle T, or he has to have or be congruent to angle A, which is across from him. So I'm going to say angle H and angle A must also be right angles. since a parallelogram has consecutive angles that are supplements. So now what we have going on here is we've got this quadrilateral with 4 right angles. And any quadrilateral that contains 4 right angles automatically has to be a rectangle. So I would say, yes, this fella has to be a rectangle. Because it has 4 right angles. All right, as always, I want you to take some time, wrap your brain around what you've just seen, think about what might be the most important ideas and the key understandings that you can take away from this video, and see if you can apply what you've learned in order to answer the questions on page 16.